This video is about a very interesting question posed by this girl, Ayla girl, on Twitter. She performs fantastic data analysis. I'll put a link down below to her website and her research. This question happened to be related to mathematics and probabilities and chance. Let's see what it is and we'll discuss it further. Imagine a circle laid flat on a table, with a little spinner on it that you can flick. The circle is 80% red and 20% yellow, like a yellow pie slice. You flick the spinner, it spins and slowly stops. Where did it land? On the red or on the yellow? Okay. Remember, we are not actually doing the experiment. We are asking people what they think happens if we do the experiment. So we know that because 80% of the circle is red and 20% is yellow, if we do this experiment, let's say 1,000 times, about 200 times it's gonna stop on yellow and about 800 times on the red. But we are asking people what they think. And the question is, what do you think happened when people answered? And one more thing before we see the results, you could not see what people had chosen before answering the question. So the choice of other people could not affect you. You would see a blank page when you are answering the question. Now let's see the result. Okay, this is the result after 77,000 votes, almost 78,000. And as you can see, the ratios almost exactly match the probabilities. So it means people chose almost 80% red, let's say here 78%, and 22% yellow, very close to the probabilities of happening red or yellow. And in case you think it's just a coincidence, she has done this another time. This is an example when the ratios are 50%, 25%, 5%, and 20% for red, blue, black, and yellow. And the final result after almost 1,800 votes or close to that is again close to the probabilities. 56% chose red, 17.5% chose blue, 15.5% chose yellow, and 10% chose black. And this one is another question posed by a different person. This is a translation from Hebrew. Basically, what it says is that we are throwing a dice, and is it going to be 1, 3, 5 or 2, 4, 6? And as you can see, close to 50% of the people answered each case, which is exactly similar to doing the experiment many times. In this one, 2,860 people voted. And this one is again the original question at a different date. I think it is like 2 years earlier. She posed the same question and the less number of people voted at that time, but again the ratios are 76% and 23.5%. Very similar to the probabilities. Now let's see, maybe it makes sense for some of you. For example, 100% probability when the whole circle is in red and you ask people to choose red or yellow, of course nobody is gonna choose yellow, everybody is going to choose red because everybody is sure that it's gonna stop on red. So there is not gonna be any surprise of that. Similar to that, if the chance is 0%, let's say the whole circle is yellow and you say, is anybody going to vote for the red? And nobody is going to do that. because nobody is stupid. Everybody knows that it's gonna be yellow. Maybe you say the same thing about 50-50. If half of the circle is red and the other half is yellow, maybe you can say, okay, it's just 50-50 and people are gonna choose either red or yellow. So in these cases, maybe you can justify the same answer as the probabilities. But why do we have the same thing for a random case of 25% and 75%? It seems that repeating something 10,000 times is the same as asking 10,000 different people. And if something has X% chance of happening, then around X% of the people bet on that. Let's see if it makes sense in other cases. The chance of winning the jackpot in Powerball is really, really low. It's 1 in 292 million. So if we go with the same logic as what happened in the Twitter question, 1 in 292 million people should only buy the ticket. But we always see that more people participate. Yes, there are many smaller prizes, and I think the overall chance of winning anything is about 1 in 25, but we all agree that most people buy the ticket for winning the jackpot. That's what is in their mind when they buy the ticket. So it is not exactly going the same way as it went in that Twitter question. Also, sometimes the expected value of the prize becomes bigger than the ticket price. And in those cases, it makes sense for everyone to participate. But we always know someone that doesn't buy the ticket. For example, when the prize goes to $1 billion, which happens many times, the expected value is going to be $1 billion multiplied by 1 in 292 million. And it's going to be $3.40, which is bigger than the ticket price, or $2. In this case, it makes sense for everyone to participate, but as I said, some people don't. In my opinion, these cases do make sense because people are behaving differently in regard to risk and tolerance of the risk and taking chances. But the question is why it did not happen for the case of the Twitter poll and the colored disk. And people exactly chose the same probabilities as the actual probability of happening those colors. For more videos like this, visit the channel and thanks for watching.